Well, hello, everybody. Good morning, good afternoon, good evening, good night to everyone, wherever you may be across our lovely world. Thanks so much for joining us here live today for, I suppose, the one and only Serverless Office Hours. We are streaming on the AWS Twitch channel and also on YouTube for the AWS Events channel. I'm Julian Wood. I'm a developer advocate here at AWS, and I'm joined by three experts because it's reInvent season, and we are talking about new things at reInvent. First up, on my top right, Debasis. Welcome to Office Hours. You have been here before. For people who don't know you, first of all, tell us what you do, where you come from, and how was reInvent for you last week?
Awesome. Hey, everyone. My name is Debasis Rath. I'm a specialist solution architect. I'm very happy to be back on the Serverless Office Hours. I am based out of Virginia. And if you know like where Washington, D.C. is, nearby, Herndon, Virginia, this is a small town. reInvent was amazing with a lot of new stuff, a lot of new people. I get to meet like all of you as well in person. So it was very happy and happening week for me.
Cool, excellent. Debasis, did you have any talks or anything that are even online? I know some of the breakouts are. So yeah, if you want to talk about what you talked about, so you can.
Yeah, I had like 3 talks in general. So 2 of them are more interactive, like workshop style, which is like building multi-agent on serverless, building Terraform on serverless as well. Both of them are like hands-on builder session and workshops. And the third one was building at scale document processing pipeline using step function and Bedrock data automation. That's the chalk talk that we did where customers were engaged and we were kind of trying to build out the whole like architecture in like 1 hour. So yeah, we got a very good set of responses, feedback, and we are looking forward to improve that experience for customers going forward.
Cool, excellent. Sisira, welcome back to Serverless Office Hours. Please let us know who you are and how your reInvent was last week.
Yeah, thanks, Julian. Happy to be back here. I'm a product manager on the Lambda team, and more specifically, product manager on the Lambda Managed Instances, which we are going to talk about today. reInvent was hectic like always, but at the same time very rewarding, talking to all the customers, getting to know like how they use our products, and also like getting a lot of feature requests too. So that was great, and now back to Seattle and enjoying all the rains and gloomy weather days here. It's been
rehydrate after time in the desert.
Yeah, exactly.
Cool, excellent. Rohan, welcome back to Serverless Office Hours as well. Let us know who Rohan is, and I like the Lambda t-shirt, by the way. And how was your reInvent last week?
You know, the reInvent week was very good. I got this fancy Lambda t-shirt here at the serverless kiosks. That was great on the expo hall. Other than that, had a few sessions, had chalk talk presentation, as well as a few hands-on builder sessions. That was great. Had a few customer meetings as well. Always a pleasure to chat with them. And, as Sisira mentioned, it was just great to meet with the customers, understand how they're using serverless today, and, things they want to see from our service team. So I'm sure Sisira will be pretty busy after this holiday period, getting ready to deliver on all that. And I'm happy to support him. And just wanted to give a shout out to, Sam the Squirrel. He had a big week last week. We showed people how to deploy applications and debug them using SAM. So, that was a great hands-on experience last week. And he now has a friend that I picked up at the expo hall as well. It's an S3 bucket. It stands upside down. So I'm collecting the entire AWS architecture diagrams here. So
swag hunters, I love it.
Yeah,
Rohan's our top swag hunter. And remember, we are live here in Office Hours. Higgy Park, we all saw last week. Higgy's our serverless expert, moving into Gen AI expert as well. Higgy also had some sessions as well, so you can look in the session catalog. That reminds me as well, also a huge amount of the reInvent breakout sessions are recorded on YouTube, and they're available on the YouTube. I think it's on this channel as well, the AWS Events channel. Chalk Talks weren't recorded, but we have got a whole bunch of awesome Chalk Talks, which we're going to be rolling out over quite over the next few months from experts who can be able to do the Chalk Talks here live on Serverless Office Hours. So we'll be able to hear the cool insights from our experts as well. So luckily, over the next few months, we'll be able to get more out of reInvent on Serverless Office Hours as well. Daryl Ruggles, who I got to meet yet again, Mr. Talks and Lambda Managed Instances, watched a video last night, some interesting uses. Well, excellent. Well, thank you, Daryl. Nice to see you again. We've got Ricardo Marquez, 1563, hello as well. And Iri Edits, welcome back as well from Twitch. We'd love to know our global serverless audience, so let us know. Tell us about your reInvent experience as well and all the things that were going on. Yeah, I had 2 talks. They're both on YouTube as well. One, best practices for serverless developers, just best practices for serverless developers. And the other one is called The Journey of Events through AWS Lambda, which is a proper 400-level deep dive with one of our principal engineers talking about all the polling infrastructure and all the stuff that you don't really need to care about because Lambda does it for you, which we're going to talk about today as well. So there are lots of reInvent announcements. We could honestly spend half an hour going through all of those as well, but we're going to rather go a bit more tight and focused. This week, we're going to be covering Lambda Managed Instances. Next week, we're going to be covering Lambda Durable Functions, the 2 big Lambda ones. And then in the following week, some other kind of things as well. Bernard Rhodes says, yeah, Chalk Talks not being recorded is always the saddest part of not being able to be in Vegas. Well, that's why we bring it for you. Bring it to you on Serverless Office Hours. And Peter Smith, properly on the other side of the world, New Zealand. Love the multi-concurrency feature sets. Yeah, we're jumping ahead of ourselves with all the kind of things. So, Debasis, over to you first. Lambda Managed Instances, what is this for? What is this solving or creating or helping with?
Great question to start with. It solves a fundamental problem of requiring a particular type of hardware when you're running your Lambda functions. So for example, if a customer wants to run today like a CPU optimized workload or a compute optimized workload, they can pick and choose those kind of instances where they want to host their Lambda function on, right? So Lambda Managed Instances basically extends the current Lambda's operational model and allows our customers to run their workloads on their specialized hardware under the hood, which they can control all by themselves, right? So that's the whole point of Lambda Managed Instance. Nothing changed in terms of how you're interacting with the function, all the ingress, like if you are using any service triggers, let's say like Event Bridge, API Gateway, SQS, SNS, all those experience would remain exactly the same, just that how they are running their functions, the compute that they are choosing under the hood, that experience now they have a higher degree of control there.
Okay, so Lambda works pretty much as it did before, all the integrations, just with some new options for hardware. Is that the...
Yeah.
Excellent. Well, then, Rohan, so that sounds all good, but what were customers doing when they didn't have this? What's because Lambda works great. We know it works at small scale, sort of great scale. What were customers doing when this wasn't an option?
Right. So, what customers were often doing is keeping their existing applications that, let's say they were steady state, high traffic, event-driven workloads that they currently had, let's say on EC2, and they kept those on EC2 since, there's potentially some, additional cost that was associated with migrating those onto, more modernized compute such as Lambda. Or if they did want to modernize, they were potentially evaluating options such as deploying those workloads on options such as ECS or EKS. And now with Lambda Managed Instances, Lambda is also another flavor of compute that they can use to build modern versions of those applications while benefiting from all the great reduction in the complexity of running them with serverless.
Okay. So yeah, then Sisira, as the product manager, obviously you've been working on this for months, not if years. Surely there's also a trade-off to make. Lambda is super simple. Get going, create something in the console, off you go. But now you've got a bit more flexibility. You've got EC2 instances to think about, which is going to freak all the serverless purists out there as well. In your sort of product decisions, how are you balancing the sort of simplicity angle with the sort of new flexibility part?
Yeah, definitely. On the last part you mentioned, I get asked often, did we put servers back in serverless? My response to that always is servers were always part of serverless. It's about not worrying about the servers, not the absence of servers. And we have kept the promise with Lambda Managed Instances too, where there are servers obviously, but you don't have to care about the servers, just like you did not with the Lambda default function types today. To keep that promise, we had to make sure that all the developer experience of how you develop the functions or deploy them, that remains exactly the same as it exists today. That we have continued. And we have introduced a new construct called capacity provider, which provides either the platform teams or the customers the ability to specify what type of instances they want us to run the functions on, and also where they want to run it on. For example, which VPCs and which subnets they want to run. And once you create the capacity provider, rest of the function creation remains exactly the same as today, and you just tell us which capacity provider to use for a particular function, and we will run it on that capacity.
So this is running on EC2 instances in your own VPC, in your own accounts, but you can't do anything with them because Lambda manages them.
Correct. We have a new variant of instances called managed instances, which is similar to the EKS auto mode or ECS managed instances, where these instances exist on your account and in your VPC, but they are end-to-end managed by Lambda. So you can't even log into them or SSH into them and install your own stuff even if you want to. And also, like, we make sure that we take care of OS patching, runtime patching, scale out, scale ins. So basically, it's a hands-off experience for you. The instances are just there in your account.
Cool, excellent. So in fact, yeah, 2 questions. And Richo Marquez, sorry, I did miss your name working out who's who in the zoo, but serverless specialist for LATAM, always welcome on serverless office hours. And you do also have a question about, as it runs on EC2 instances, is there no way to run without VPC? And Hannes 1980 HR GOG says, can it run without a VPC? And the answer would be no, because you need an EC2. It needs to be in an EC2 instance.
A good call out here would be now, if you compare it with the existing Lambda model, how it runs, your VPC and networking is controlled at the function level, right? So you put a VPC and subnet and security group configuration on each function. In contrast, on the capacity provider that just Sisira mentioned, so you have to put a networking configuration on the capacity provider that every Lambda function that is tied to that capacity provider will now follow the networking constructs that you have applied on the capacity provider. Right? So that's a little bit of difference. And because we are allocating the capacity and also configuring the networking configurations, you cannot run that function without a VPC or a capacity.
Okay, and yeah, and we do have Divas. Thanks for joining us for our YouTube. Would managed instances lambdas mean if can set networking set up an instance, do not need to worry about this on individual lambda functions? Yes. So I think we're surely gonna get ahead of ourselves on lots of all the nitty gritty. But I think let's just maybe we walk through the architecture at a high level. So Rohan, we've mentioned capacity providers, EC2 instances, and VPC. Blah, blah, blah. Do you want to just give us a little bit of information about this capacity provider concept and what that looks like?
Sure. So a capacity provider is a new resource type within the Lambda service, and a capacity provider is essentially going to be a pool of EC2 instances that your Lambda functions, one or many different Lambda functions, can be deployed on. And so within each capacity provider, you have the choice for saying how many instances you want active, as well as like a minimum and maximum levels, as well as which instance types you want available. Or you can let the Lambda service decide for you, and that's another option if you want even more of a managed offering. And the Lambda team will basically evaluate the workload and see which instance type would be most appropriate. Or of course, you can select which instance types that you would like to be provisioned in your capacity provider. And then, as Debasis mentioned, the experience of putting your Lambda functions on those capacity providers and deploying them on there is very, very similar to what customers are already used to with standard Lambda functions that they've been using so far.
Cool, excellent. Yeah, and we'll definitely have a quick look at the setup as well, but I want to get the architectural stuff in advance. So we've got a capacity provider, which is a sort of logical pool of compute capacity, and you can pick individual EC2 instances. You can add in EC2 instances, you can exclude EC2 instances, you can say Lambda just figure it out, or you say I want D instances or Graviton instance, whatever kind of instances, and you can get Lambda to figure out with a pretty much a full suite of EC2 instances, which I think is the actually really simple model, is just get Lambda to figure it out, and then you create a pool of virtual CPU resources. You can have minimums and maximums, and then Lambda is going to figure out stuff in the middle as well. But part of that is about scaling. So Debasis, I know you had some interesting things about scaling because we know Lambda scales 1,000 concurrent instances for every 10 seconds and can has previous burst scaling. All this other scaling doesn't quite work the same with managed instances. So can you walk us through what the scaling story is?
Sure. I mean, we are talking about capacity here, right? So capacity is like capacity provider gives you a specific amount of capacity. So you can say that, hey, I want a total of 100 vCPUs for all my Lambdas that is sharing my capacity provider. That's it, right? So you're setting a ceiling of like how much capacity that you want all of your Lambda to share at a given point of time. Now, again, what we do behind the scene is like when you create a Lambda function and publish a version, obviously that's a mandatory step that in order to create and provision your capacity behind the scene. What we do is like we start with a baseline number, right? We say that, hey, the customer has selected these many number of AZs for this particular VPC, and the capacity that they require is like around like 100 vCPUs. We'll start with like a baseline number of EC2 instances equally distributed across all those AZs, right? So that guarantees fault tolerance, and we start with the baseline capacity. And based on the type of load that you're getting towards your Lambda function, let's say I'm sending like 100 requests, gradually incrementing towards like 1,000,000 requests or something like that, we slowly scale up those EC2 instances based on the CPU utilization in the capacity pool itself. So a baseline number, we have a ceiling, and based on the load, we gradually scale your Lambda managed instances up to the maximum load. And then,
carry on.
No, I was just saying that then we also have like a little bit of control on each function level. So there are two scaling constructs here. So how much scaling that you can get at the capacity provider level, the capacity and the scaling. And then there is a little bit of scaling control on the function level as well. So we can probably discuss about that in a minute or so.
Okay. So this is really for steady state, probably high scale workloads. Maybe I'm going to flip the question around for Sisira. When should you not use managed instances, or who is this not for, or why would you not use this?
Yeah, I think just to set the context there, when you create a Lambda function, we are now offering two different compute types. One is the Lambda default, which is today's Lambda, and there is also the Lambda managed instances. So Lambda managed instance compute type is not a replacement for the Lambda default compute type. It's more of a complement to that. If you have infrequently invoked functions or low traffic functions or super spiky workloads where you can't predict the pattern of the workload, Lambda default is the way to go, where we could spike up to, like you're saying, 1,000 concurrency in every 10 seconds, and you don't need to give any heads up to us. So that's still the way to go. However, if you have workloads which are either needing specialized compute configurations, such as a higher CPU to memory ratio or latest generation of CPUs, or you have the large scale predictable workloads where you can sufficiently say hey, this linear scaling pattern would work for me, or you want to use your EC2 committed usage discounts across your different compute services. Those are the instances where you want to use Lambda managed instances.
Okay, so there's a EC2 capacity kind of thing where you need super network instances or big memory instances or big CPU instances, or you want to have more control over that. And then also at a steady state workload, because you can apply EC2 pricing things, it may be able to be cheaper for you. But obviously you're going to have to work out your figures, I think, and work out what the EC2 commitments are going to be, what the pricing model is, and then figure that out on your steady state workload. And I suppose because it's a steady state workload, you'd have more of an idea to be able to understand your costs rather than having to factor in unsuspecting bursts and things like that.
Yeah, I just want to add there that we support all the pricing mechanisms of EC2, whether it's EC2 savings plan, compute savings plan, reserved instances, or enterprise discount. So all of them are supported. So.
Okay, perfect. And then just from the pricing perspective, there is, you pay for normal EC2 instances, and then there is a 15% management fee on that as well. And that's for the capacity provider. And then on the Lambda, you do pay for the requests, but you no longer pay for gigabit seconds. So anyway, you're swapping gigabit seconds for EC2 plus 15%, and then the Lambda request pricing would work is the same for both.
Yep, that's exactly right.
Okay, excellent. I know there was a video we were going to show as well, just for some setup. I can't remember quite what it was. So let me know so we can play it at the right time when you want to jump in. Otherwise, you know me, I'll just carry on chatting away. So let me know what's good to show. Where were we? The other kind of thing. So we spoke about the capacity providers, we spoke about the scaling, and then the other sort of, I think, exciting thing is this sort of multi-concurrency. Sisira, this is multi-concurrency, but it's sort of managed multi-concurrency. How should people think about that?
Yeah, so I think again, just to refresh memories of people who have used Lambda. Lambda used a single concurrency model today for the Lambda default functions, where when we spun up an execution environment, it would process only one request or invocation at a time, and only once it was done with it, it would pick up the next request. However, now that you are running your execution environments on the EC2 instances, and also there are multiple functions possibly sharing the same capacity order, we thought about ways of making it more optimal, or get better utilization on your EC2 instances. And one of the avenues was introducing multi-concurrency. So what that means is each of your execution environment can handle multiple Lambda requests or the function invocations at a time. This is hugely beneficial if your requests were not completely utilizing your CPU in the execution environment, or they were just waiting for IO. Now the request to the same function can more optimally utilize that execution environment, and thereby your EC2 instances, which means cost savings. So that's the whole concept of multi-concurrency. And customers don't have to worry too much about these multi-concurrency settings, because we have defaults based on your function language and CPU configuration. Obviously, you have controls to override them and tune it for your workload. But if you go by default settings, it should work for most use cases. Another call out I have to make here is, because now the functions are multi-concurrent, you have to make sure that the function code is thread safe. If you are used to writing thread safe programming in any of the other compute services and follow the best practices, it shouldn't be a concern for you at all. But however, if you are used to a single concurrent model, then you have to make sure that you are not using things global mutating states, where requests of your same function may be overwriting each other on a shared memory space, or /temp, or you may be setting up database connections which you are reusing between the requests. So they're using thread safe practices, using database connection pools, or not using mutating global states would be a requirement for being thread safe in multi-concurrent environments.
Okay. Yes, so that is a departure from standard Lambda single execution environment. Everything is bound. Everything is good. But yeah, to be efficient with your cost and using your EC2 instance, there is multi-concurrency. But yeah, and I suppose all the languages would be slightly different in the way they do things, because of course this is IT and programming, and we don't have the same kind of things. So I think, Rohan, you mentioned also as well on our Lambda Managed Instances, there's a getting started guide. In fact, I will put that into over here, and then there's a runtime section which actually has information about all the different runtimes, because Java and OS threads, and I suppose Node with workers and all things like that would all be slightly different. So I'll plonk that in the chat.
Exactly. And one more question, I guess, on behalf of our customers. So customers are pretty used to understanding reserved concurrency and provisioned concurrency, and how will their mental model of those shift when applying that to LMI? I'm sure the answer is it's different.
Yeah, so like I was saying, you had a very 1:1 relationship between how many requests your function gets and how many execution environments you need at a time with the Lambda default. So that's where we had the concept of concurrency, which would basically linearly scale with how many our requests your functions are getting at a time, right? So customers had to very carefully control these two constructs. One was the reserved concurrency, which meant what's the guaranteed amount of concurrency you want for a single function. And there was the concept of provisioned concurrency, which was to tell how many warmed up execution environments you need for your function, which would avoid the cold start latencies. However, the concept changes quite a bit with Lambda Managed Instances, where you have pre-provisioned instances with pre-provisioned execution environment. So there's no concept of cold start. Like Debasis was saying earlier, we scale by CPU heat, and when we reach thresholds, which is again configurable, we would spin up more instances and keep more execution environments warm, so you wouldn't hit the cold starts. And at the same time, the concurrency which we are talking about here is how many concurrent requests can land on each of these execution environments. So you are able to configure that like away from all defaults, and basically like how many execution environments you have, and multiply them with the concurrency setting. That's how much concurrent requests you can handle. And again, like, to reiterate, you can configure the concurrency per execution environment, and you can also specify the number of minimum execution environments you want if you want to have that pre-provisioned warmed execution environments.
Okay, so yeah, so that talks about the scaling things, but account concurrency, is that still a factor for Lambda functions on managed instances?
Not anymore. So there is no fixed concurrency limit per account. It's all based on how much our EC2 capacity you can provision on your account. The vCPU limit we have on the capacity provider is basically that cost control, or the limiting factor on how much you want us to scale your functions up to. But I mean, if you leave that empty, we will scale up to how many our instances can be provisioned on your VPC based on your EC2 limits.
Okay, so that also means that the minimum on-demand Lambda function is 128 meg, and the minimum Lambda managed instance is 2 gig, but it's up to 32 gig instead of 10 gig. So, and because we want to be more efficient and run more multiple concurrent connections within that Lambda function. I'm trying to think of what well, it's actually a container. You can even say, yeah. Yeah. So yeah, just talking about that. Yeah, thanks. So our Lambda functions exist on the new managed instances. Do they both run in EC2? I thought they used to run on some specific container technology called Firecracker. Am I correct? Who would like to cover this?
Yeah, I can take that. Understanding is right. Today, Lambda functions run on instances, but there is a distinction. We run a huge pool of metal instances, bare metal instances on Lambda's account. And because we have this shared pool of or fleet of instances which we share between our customers, we use a technology called Firecracker micro VMs to run the customer's functions. That provides us a very strong isolation boundary between the customers, which is necessary because this is a pool which is shared by different customers. However, when we move to the Lambda managed instance model, the functions are running on your account, and it's only like used by you. So the security boundary changes to the capacity provider, and also we can now use Linux containers to run your execution environments. What that enables is obviously you are still secure because it's an environment just shared by you, or not even shared by you, like it just belongs to you. And it also allows us to run on a wide variety of EC2 instances, not just the metal instances which we run on Lambda's account. So you are now able to pick any of the CMR, which is compute memory and general purpose families of EC2, ranging from wide variety of generations, Intel, AMD, Graviton. All these instances are now available with this new execution model. So I guess the TLDR is Lambda managed instance execution environments are containers compared to the Lambda function environments, which used to be Firecracker micro VMs.
Cool. So yeah, Firecracker not being used for this, container D as the isolation mechanism, but also know that within that container D, there are lots of different security, sort of layers of an onion, which we also use on Firecracker, also use on Lambda managed instances. But yeah, I suppose that is a consideration if you have a requirement for hard virtual machine isolation, or you may be running, a SaaS provider or that kind of thing, and it's not the same guarantees that you're going to have between micro VMs, but normally you would be an enterprise or you'd be a big company wanting to do a steady state workloads, and so you would probably you would trust the containers as you would in an EC2 world or something, and even Lambda's got even more protection within those containers as well. So
yeah, just to add another consideration is if you want a clear separation between functions within your account, then you could also create multiple capacity providers and associate those functions separately to those capacity providers.
True, yeah. And then also the inverse, you can have multiple functions on the same capacity provider. So it isn't a one-on-one. So yeah, if you can create your pool of compute capacity and then throw as many functions as you need at them, if that suits you, or maybe different organizations within your organization, or you have some functions that are memory bound, some are network bound, all the possibilities of EC2 that you can do.
Yep.
There was another question. Well, Heggie said, good to show that the reinvent T-shirt you had in Vegas. Yes, well, Higgy is talking about a still serverless T-shirt with Eric Johnson and my faces on it, because of course we're still doing serverless. I think it would be slightly inappropriate, and I don't want to close the stream off by taking off my T-shirt and swapping a T-shirt live on stream. So I'm sure we can find a picture of that as well, rather than freaking everybody else out as well. And then Hannes, you also had this question: does running in VPC, it means it would have degraded performance compared to non-VPC? I would say no. As with all things EC2, it's bare metal instances. There's Nitro running the virtualization layer, which is separate from, it's not taking away CPU processes as well. So hey, you've literally got a bare metal node, and we are sticking in some containers on top of that.
I in fact want to add to that, Julian. So today's Lambda function execution environments had a certain fixed network throughput. But now if you choose, say, like a network optimized instance, you can have orders of magnitude more bandwidth for your individual function execution environments running on EC2. So.
And
good call.
If I can add one more, right? So as Sisira was mentioning, there is no cold start anymore, right? So when you publish a version, you create and publish a version of a particular function, we create execution environment, at least like a baseline number of execution environment. We'll keep it hot and ready. So you don't see any cold start. We do all the networking magic for you. The instances are ready. The ENIs are ready. So all the infrastructure for you to do certain networking is already ready for you, so that you can go and use those in your data plane operation when you invoke the function, right? So there's no performance degrade. And on top of that, as Sisira mentioned, you will get better throughput if you select a better, like a EC2 instance.
Okay, so well, Debasis, do we have that video to actually show the capacity provider creation? Do you want to show that now, or is it better later? Up to you. I don't.
Like your call. I mean, like I wanted to have it like at the end, if we can get, so we can cover all the concept. But
okay, that's on. No. Let me know what time. I don't want to run out of time and then we miss what it looks like as well. So then let's, I suppose, talk about what actually happens. So you create a capacity provider, and when you create a capacity provider, you're providing these instances, not these instances, whatever you're going to do in the size of the capacity provider. But when you create that, it doesn't actually do anything. It just, you've sort of created a logical capacity provider. When you then create a Lambda function, you then target, and you literally select, I want to target this capacity provider. There's one or two of the scaling kind of settings. And then once you click OK, and also you do need to use a published version of a Lambda function to do this. So same with, like, in fact, people, if you're doing provision concurrency, if you're doing snap start, if you're doing Lambda managed instances, you need a function version. So just function versions are there for your friend. So if you're doing this in the console, it will automatically publish you deploy your function, and then when you publish your Lambda function, what it's actually going to do is it is going to look at the config of that capacity provider. Basically, the first time that capacity provider is created, it's going to spin up those. Well, Lambda is going to spin up those EC2 instances. We haven't covered that, but there's an operator role, which you give Lambda to give you permissions to do that. So we spin up those EC2 instances. Once they have the health checks and tell Lambda we're good, then we actually go and deploy containers with your Lambda function that's going to run. And then we run those containers. And what are those containers going to run? Your initialization code, waiting for an invoke. So am I correct? That is the sort of pathway that, and then if you then update your function with some code, we actually provision new containers, we delete those old containers. So there is also, this is why Lambda Managed Instances isn't huge for a big scale up, because there is a provisioning process that needs to happen. It's only 1 or 2 minutes. In fact, it's actually surprisingly quick how it does it. If you think we are basically going to your EC2 instances, deleting a bunch of containers we've created before, spinning up some new ones with some new configuration or some new configuration from the code and configuration from the performance profile as well. So that's why it takes a bit of time to provision. So we're actually spinning up containers on that instance, and then behind the scenes, as you scale up, we'll go and deploy either new instances, or we'll add new containers onto existing instances. And sort of Lambda quite cleverly, I think, figures that out. And there are some scaling things you can set that as well. Schizophrenic Web Developer says containers are running on EKS. No, they're not actually running on EKS. They are just running on EC2 instances. There's no Kubernetes layer behind the scenes. As Sisira mentioned, EKS Auto Mode, EC2, ECS managed instances and Lambda managed instances are all part of the same kind of thing. And actually, it's all an EC2 API, and that EC2 is built helpfully for these other services to become more serverless. So we can say that EKS Auto Mode is Kubernetes becoming slightly more serverless. No lightning bolts are zapping down my head. So hopefully that's not too much heresy. So where did we get to? I was rabbiting away, and we were going through some questions as well. I think we're good with the questions from that as well. So yeah, what did we get to? We were talking about multi-concurrency. We were talking about all that with different programming languages. So yeah, I mean, Rohan, are there any tips and tricks for developers on the programming language style, or do they just look at the documentation? Is there anything they should worry about immediately if people don't want to, they've got some existing code, they think managed instances is great, they're going to take the existing code over? Any things to think about? Or
Yeah, exactly. So as mentioned earlier in the webinar, we do have some considerations for each of the supported runtimes, and we've published that as a best practices guide in the documentation in Lambda. And so I'll make sure that gets uploaded to the chat right here, so that as users are considering migrating to LMI, they know exactly what to look out for, any gotchas there are for their favorite programming languages.
Okay. I'm just thinking. So yeah, and I'm just thinking in the back of my head. Well, in fact, here's Daryl Ruggles asks, how long until custom runtimes like Rust would be supported?
Yeah, it's definitely on our plans. So today we do publish the base AL 2023 image for this. So you could technically implement your own rig and bring custom runtimes here. But definitely like more languages like Rust are on our roadmap for this.
So Sisira, what runtimes are supported at the moment? Or
so
all the
today we
ones?
support Java, Node.js, .NET, and Python. The latest versions of those. For example, like in Python, we support 3.13 and 3.14, Java 22 and above, Node.js 22 and above, and .NET 8.
Okay, cool. Excellent.
So I think, Julian, we were sort of fishing for topics here. So I have one topic I would like to bring up if you don't mind. So
please.
Yeah, so I think one important consideration for customers, whether they were running Lambda earlier or now with Lambda Managed Instances, is how do they operate it, right? So how does the observability work, or how do secrets management work? Like all this accessory tooling which they're familiar with. So the thing with Lambda Managed Instances is we have kept that whole experience intact, where Lambda had this extensible model with layers where you could bring the extensions from third-party providers, say like Datadog or variety of vendors we have. So today we support that on Lambda Managed Instances too. So you could use one of the third-party providers or even other AWS tools such as the AWS Lambda Insights. The extensions are supported on this model too, and you can have the same experience. And the same thing with the other first-party telemetry, which is CloudWatch logs, X-Ray, and CloudWatch metrics. All the same metrics and logs are supported. There is one distinction on the CloudWatch logs, where earlier in Lambda, the logs would traverse within our VPC and reach CloudWatch logs endpoint. However, with Lambda Managed Instances, since the compute is on your VPCs, the CloudWatch logs will traverse through your VPC and reach the CloudWatch log endpoints. So one consideration there is you have to make sure that your VPC has access to these CloudWatch log endpoints. You can either have a public VPC with a internet gateway, or you could configure a NAT gateway, or just expose the VPC endpoints of CloudWatch logging endpoints. So any of those mechanisms work. We just want a route from your VPC to the CloudWatch logging endpoint. So that's one consideration with logging. X-Ray remains the same. We support the X-Ray SDK, and then CloudWatch metrics, we do publish all the existing metrics. But in addition to that, because there is a new concept of capacity provider, we have a variety of new capacity provider metrics as well, which gives you details around what's the utilization of the instances across my capacity provider, or how many instances do I have, what's the scaling behavior. You can get all those metrics with the capacity provider metrics. We also support the other extensions which I was alluding to earlier, which is app config. So if you have some specific app secrets or app configs which you want to not have hard coded in your function code, you can use those extensions too. So.
Okay. Excellent. So yeah, I mean, there's very little that actually changes from other than this capacity provider. It's not a trade-off of, oh, well, you can't use this of observability, or you can't use extensions, or this kind of thing. So yeah, that is actually really cool. That this just unlocks some more use cases without having to make some sort of serious product and tool trade-offs. So yeah, Pergam Rod, thanks for joining us via Twitch. Still 15-minute timeout.
Yeah, the execution environments still are bounded by the 15 minutes timeout here. We are evaluating whether there are possibilities to increase that, but at least for now, it's 15 minutes. So.
Yeah. Now, I know internally there's been a huge amount of discussion, because I mean, technically we could run Lambda functions for years. I mean, why not? It's just some compute kind of thing. But if you think about it, when a Lambda function is running, how are you going to find out what's going on inside? How can you peek inside to work out what's going on and all that kind of thing? So we'd actually really love to hear feedback on this as well, of because lots of people are like, oh, of course we want longer running Lambda functions. And then when you sort of ask the questions, well, how are you going to monitor that? How are you going to know if something bombs out? If it partly bombs out, you're doing multi-concurrency and something messes up into a job that's 17 minutes in, how do you know? So yeah, it's the Lambda service also wants to be opinionated, because we don't want you to basically mess things up, make it too easy.
Also, please share the use cases why you are looking for 15 minutes or more. That would be helpful for us.
Yeah, definitely. But then Daryl Ruggles, yes, Rohan, carry on.
Week for next week's office hours is exactly what Daryl mentioned. Durable functions is also an option for those longer running workloads. So that's something else to consider as well.
Yeah, so durable functions works all fine on managed instances?
Correct. Yep.
Okay, excellent. Well, with a quick TLDR, durable functions, we are going to be covering that next week. Basically, you run your Lambda function up to 15 minutes, but you can stop and checkpoint it, and it can check and wait, idempotently stores its state, and then when it comes back, it can just run another invoke up to 15 minutes, and you can carry on doing this up to a year. So I mean, that's a sort of very high level part of it. We'll cover more next week. But yeah, a whole new way of doing distributed workloads, workflows, distributed workflows as workloads at scale. So yeah, Figuremod also said, all invocation modes supported, sync, async, and polars, event source mapping. I think Sisira, you said that is all correct. So.
All invocation modes supported and all the existing event sources supported.
So,
okay.
Julian, if you want to pull up my screen, I want to show like a little bit right over here, right? So this is what we showed in reInvent as well. So the little bit of difference that we need to understand the invocation model, right? So all your invoke APIs are the same, whatever you are using right now, right? So every time you go to your AWS CLI, so that AWS Lambda invoke, all your request lands on our front end, which is like Lambda Managed Services, like front end. That's where like you see that Lambda service as an icon. And then Lambda service does that magic under the hood to route your request to individual execution environment behind the scene to your own VPC, where we have like spin up those capacity, created those execution environment, and kept them hot and ready for you, right? So the ingress model does not change. That's where like all our triggers, everything that we talked about, like sync, async, polling models, whatever that you have used till this point, everything would remain exactly the same. Just that how you are spinning up the capacity and hosting your compute under the hood, that is changing.
Cool. Yeah, that's great to know. And so I suppose for people then thinking, oh, now I've got another egress into my EC2 instances in my VPC. How do I protect that with, security groups and firewalls and all that kind of thing? Well, the thing is that the invoke is still coming via the AWS Lambda service VPC, and then just instead of being forwarded to EC2 instances in the Lambda account, it's being forwarded to EC2 instances in your account, and the rest of everything applies. So the Lambda polars, for example, still run in the Lambda VPC. When it's an async invoke, SQS queues behind the scenes, you don't see them. They still run in the Lambda service VPC. Cool, excellent. That is a good slide to do that as well. I'm not sure, MadS27, is this like a neural network between nodes? What quite we meaning? Does anybody know? Not sure. Anyway, let us know. And Mr. Jay Shankar 8870. Sorry, I've messed up the beginning of your name. Reading it far too quickly. But when there is a scheduled Lambda using event bridge rule, can there be more than one concurrency of the Lambda? Yes, depending on how you're running it, I suppose. If it's a Lambda function that's only going to run once, there's going to be one concurrency because it's only going to run once. But if you're kicking off a lot of schedules while a Lambda function is already running, say an event bridge rule runs, a Lambda function runs for 10 minutes. If you run 10 of them at the same time, you'll have 10 concurrency. They may land up all on the same EC2 instance as well. Excellent. So I know we want to get into the demo, but just quickly before we do that, what is the sort of best practices or advice or thinking if people want to start or what they want to do? I mean, there is a slight caution I have here because it happened to me that because you got the full instance of EC2 instances, I set up a capacity provider. I've got a video I've recorded. I did this a few weeks ago before it was done. I wanted to test the scaling limits, so I set a capacity provider of 1,000 virtual CPUs, and then the bill is going to increase for that if I set a minimum which is very high as well. If you are playing around this in your account, these are real EC2 instances. There's real money that's going to be spent as well. But other than bill shock for me being a poor developer, any best practices before you get into the demo?
Yeah, I would say that customers should really think about, okay, which of my workloads has high traffic already, and it's steady state. It's not very spiky. That would be something that you would want to consider as a potential workload for LMI. Additionally, I would say that if you're only interested in LMI for, let's say, the cold start benefits, if you haven't already evaluated features like provisioned mode or snap start, those are two, of course, to consider, which may get you those performance gains that you're looking for without the additional cost overhead of LMI.
So for a cold start mitigation, try the other options first. Lambda Managed Instances is not necessarily the first go-to to reduce cold starts. Makes sense. No. Cool. Debasis, should we show the video and then at least we can see what things look like? Can I share your screen or?
Absolutely, pull it up. Let's see.
Here we go.
So, this is a recorded video demo that we did to give you an experience of like how you create your first LMI function and create the capacity provider, which is the main engine that gives you capacity and networking configurations and everything. So let's jump right into it. Let's see. So if you see here, I'm trying to create a capacity provider. So you get a whole new menu item on your left-hand side menu that says like capacity provider. You see that orange bright button on the right-hand side corner, and you click on that and you can create your capacity provider. So let's start doing it. So you start with like providing it a name. So you want to uniquely identify your capacity providers. You set up a VPC where you want to run your capacities. You provide subnets. You provide like 2 or more subnets based on like how fault tolerant you want your functions to be. Remember, like when you create more, when you associate more subnets with your function, we try to balance out those capacity across those subnets. And in case one of the subnet goes down, your request would be routed to one of the healthy other subnets, right? So that's how Lambda makes it fault tolerant. You also put a security group under the hood to make sure that your egress traffic is happening in the right way. And then this is the important, like a permission. This is something called operator role. This is how your Lambda function, Lambda as a service, comes into your account and tries to create those instances for you in your EC2 service, right? So you're basically using this role's permission to allow Lambda as a service to come into your account and create those EC2 instances for you. That's it. So once you have defined all this, then you can do other configurations, advanced configuration. You can select the architecture of EC2s that you want to like deploy. For example, like if you want to run a ARM-based Lambda function, so you have to select ARM. Again, like that's a catch. So you cannot create a capacity provider with x86, and you cannot run a ARM Lambda function on top of that. So make sure that the architecture that you have selected for your capacity provider, the same architecture is also selected for your Lambda function creation too. Now, there is also selection of like instance types. So you can say that, hey, these are the instances I want to limit my Lambda function creations on. Or you can, it's an either or kind of scenario. Either you can use like allowed instance or excluded instance, right? So you cannot use both. So you can say that, hey, run all of my Lambda function on this instance, or exclude this instance and use everything else, right? So right now, as Sisira mentioned, if you have remembered a while ago, we support like compute optimized, memory optimized, and general purpose instances at this point. Now, important thing here is like this works as a control mechanism, which kind of like a capacity that you want to provision. You can scale up like your vCPUs as much as you want. Let's say like as Julian just now mentioned that, hey, you can put like 1,000 vCPUs in your capacity provider and things would work out. Yes, we can scale up, but again, this is a cost control. Make sure that you don't remember, like we are talking about like reserve concurrency, how it can control the higher level of like a ceiling level of scaling for your function. The same way, the maximum vCPU count that you see here, that text box, the number that you put in there would decide the maximum capacity till which your Lambda function could scale, right? Again, how that scaling would work, it can be controlled with two knobs. Either it can be automatic. You like you output that responsibility to Lambda as a service to do either auto scaling, or you can also select a manual aspect where you can say that, hey, monitor my CPU policy, and based on that you auto scale, right? You can select both of them. That's it. So once you have all this figured out, you go and create your like capacity provider. Right now, I have like these two capacity provider on my end. I have a memory intensive capacity provider. I have a like a compute intensive capacity provider for high concurrency and all of that. But yes, as you see, you will get a list of capacity provider, and you can go into individual capacity provider to see all of your configuration. And you can also see other controls like allowed instance types, like excluded instance types, and everything, right? It's as simple as that. Now, it's important for you to understand that like if you go into each and every capacity provider, you'll also see like what are the different functions that are associated with it. We're going to deep dive into that as well. All right, so now that my capacity provider is created, let's go and create a function for it, right? So creating a function takes almost like 80% of the time, like the same route that you have created. Give my function, give a runtime over there. Architecture is important. If you have created already a capacity provider, make sure that you select the same architecture over here. That is very, very important. You give an execution role, that experience doesn't change. So two roles over here. One operator role for your capacity provider that would allow Lambda as a service to come in and create EC2 instances. This one on the other hand would give you those superpowers to Lambda function to do additional tasks like, hey, go write it to S3, go drop a message to SQS and all of that. So important distinction between those two roles. All right, so then additional configuration, this is where you select your LMI configuration. So you have two options over here, Lambda or Lambda Managed Instance. I am habituated with calling it LMI. So these are the LMI configurations over here. When you click on that one, you will see how to select a capacity provider, right? So here I have like two capacity provider. I can choose either one of them. And again, important that the architecture you are selecting for the function should match the capacity provider. Now, the interesting thing here is like memory and execution environment memory to vCPU ratio. Remember that your smallest LMI function that you can create is of size 2 GB. But based on this particular ratio, you can control how much memory to CPU ratio that you want on your function. For example, if I'm running a compute intensive workload where I need more CPU, then I'll keep this ratio like very small, like 2:1. If I'm running just like a huge memory intensive application, I need more RAM, not a lot of CPU, I can flip it to 8:1. And using that, I can say that, hey, this function may not require a lot of CPU, but it requires a lot of RAM that can be used by my function code, right? So you can have that particular like a ratio flipped around to give that function execution environment the right ratio of memory to vCPU. Again, like the networking remains the same, security, everything else is going to be exactly the same that we have already discussed about it. And the networking and security will be controlled at the capacity provider level. Now that I have created this function over here, the main important aspect over here is to go and create a version. Remember that when you create a function and like just use the latest, the function stays in a like a different state where you cannot invoke it. So you have to go and publish a version in order to have a invocable version of that particular function. So let's go and create a version of it, right? So I have created a bunch of version here. So creating version also is the same API. We haven't changed a lot in there. So you just publish a version, you will see it in the versions tab. The aliases and versions would work exactly the same. The only difference over here is when you publish a version, that's when we go and create those EC2 capacities behind the scene, and then we pre-provision those execution environment, and that creates like that gives you the same experience of like what you have seen in provision concurrency, right? So if you like apply a certain provision concurrency in the existing Lambda, you would see that we create a certain execution environment always hot and ready for you. The same way, when you create a version in LMI, we do the same thing. We pre-provision your Lambda execution environment and keep it ready for your incoming invocations.
So is this also a tidy up exercise that if you keep a lot of versions around and you're not actually using them, that they're going to take up capacity as well? While if you're not using them on demand and you don't invoke them, doesn't really matter, sort of.
Yes. And if you have a pipeline, let's say right now that you're managing that keeps creating like a lot of versions, you also put a platform strategy that, hey, if there are like a lot of trailing older versions, you keep on cleaning them up if you're not using them. All right, so looking at the configuration on the function level, this is what you see, like how much memory I have set up per execution environment. Then this is important, the min and max, right? So here we are saying that like this control that you see here with the like a balloon on top, it says maximum concurrency per execution environment. So this decides how many concurrent invocation can be hosted on your execution environment. Let's say if you want to like tune it to something less than 8, like 5 or 6, you can control that using this particular configuration. Now remember that these multi-concurrency of a particular like a Lambda function is controlled at the runtime level as well. Each runtime, for example, Node would have a different number compared to what Python has. I have created like a Python function over here. So the max concurrency that I get for a Python function is 8 at this point. I can go sometimes like lower than 8 as well. So the control is right over here. That is called maximum concurrency per execution environment. Now, the second thing is like this one we discussed already, like execution environment memory for vCPU. Min-max control. This is very, very important to understand the baseline and how you scale, right? So when you say a particular, you set a minimum value for this function scaling configuration and maximum value, what we say that, hey, when you provision a particular version of a Lambda function at a given point in time, we will spin up the minimum number of execution environment and we will keep it hot and ready for you. And based on the load, we will go up to the max number of execution environment that you want, right? Now, this max number of execution environment, again, is dependent on how many EC2s are already spun up for you based on your availability zone, how many vCPUs that you have configured on the like a capacity provider. So all these are like intertwined with each other. So make sure that you find out the right min-max values for your function, the right baseline capacity on the capacity provider, and you tune it to make sure that you can accommodate all that steady state traffic that Rohan was talking about while you are provisioning your version, right? So it's very, very important. And make sure that you tune them based on your traffic pattern.
Cool. Debasis, we have about a minute left. So is there what would you like to quickly show? I don't want to rush you, but
yeah, that's about it. Once you are done with here and like you're ready to go and invoke your function, everything else remains the same. I had like one more piece where I would say like, hey, these are the logs that we would see like in a multi-concurrent environment, but that's about it. So you can them over here. Yeah.
Cool. Excellent. Daryl had a good question before. Sisira, the elephant in the room, which I thought we should have done earlier. GPUs for Lambda. Everyone wants to know about GPUs. I know that's been thought about. What would you like to say about that?
Yeah, definitely. We are evaluating options there, but at this point, there's no GPU support. We support CM and R families and a variety of instance types there. You could go to our pricing page to see like all the different instance types supported, but GPUs are not yet supported.
Cool. Excellent. Yeah. And I mean, the weird reason for that as well is actually fractional GPUs is a super hard technical problem. It's not just a Lambda kind of thing. Everybody's trying to figure out how we can do it the best way. Please also send us your questions in your comments. We'd love to know. Thanks, everybody. It was a great walkthrough. I enjoyed the video, enjoyed the chat. Yeah, lots of information. I think it's a super exciting new branch out for Lambda. If you have steady state workloads, if you freaked out that you're never going to try Lambda because, oh my word, costs are going to spiral out of control, this is a great way you can expand into Lambda, go as big as you want, but control your control the upper bound of Lambda as well. Yeah, lots of exciting things. Yeah, Debasis, Rohan, Sisira, really appreciate your time today. Next week we get to talk all about durable functions, the next exciting installment of Lambda. Thank you very much. Same time, same place next week. Bye-bye, everybody.
Thank you.
Thank you, everyone.